Okay, so let's get started, okay? Let's continue our talk on chapter 10, data abstraction and object-oriented programming, okay? So today I'm going to do this. I'm trying to go through these slides first and see if I have enough time, then I go through examples, okay? So last time we actually finished the garbage collection. So today let's looking on the polymorphic method and the mixed-in inheritance. So basically talking about the class-to-class relationship, but mainly on the dynamic linking and dynamic binding and polymorphic method. Okay, so first let's look at what is dynamic binding. Okay, static binding is easy. You actually have main function, and then there's a f function. You call f function, so f function defined somewhere, and then come to here, you jump to the edges, finish that, you come back, right? So that's whatever we know about static binding. So the location at the compile time, you should be able to know it, right? You know where it is. At least you know the relative edges you can put down to here as the return edges. You actually know, okay? Dynamic binding is different. At compile time, you have no idea of which function you will run. So see here, we have a class called flu, and there's another class called we have a class called base class called flu, right? And there's a derived class called orange. Okay, two different classes. So conceptually, we have a base class called flu. Okay. And there's another class called orange. So orange actually extends the flu class, okay? And here we have different object, okay? So the base class, we have constructor, destructor, it, PO, set color, and color, okay? And there's something called read table. So right here, we are looking at C double plus method. C double plus use read table, okay? Virtual table. So derived class, you have orange, you have it. So you don't have in the derived class, you don't have the PO, you don't have the set color, you don't have the color method, okay? So you don't have these different methods here, this one, you don't have, okay? So now we new flu, okay? So new flu one is a flu object. Flu one is flu object and flu pointer. Okay, flu one is a flu pointer. Flu two is actually a orange object, but flu pointer. Okay, it's an orange object. Flu three is also a orange object, and actually also a flu pointer. So three of them all are flu pointer. Okay, so flu pointer means that these pointer need to behave like a pointer for flu class, but their object in reality are different. Okay, so now flu one it. Okay, flu one it. Actually, flu one is a flu object. So actually, it go to see it. So it eat by this if function. You go back to the v table here and find this if function over here. Is that okay?
Yes.
Yeah. Flu two actually is not a base class, not a flu object. So it actually go to here and find v table, and if find v table actually it's actually this v pointer will point to here and then find the it over here. Is that okay? Yes. So basically, on the object, they will have the v pointer, and this v pointer will be pointing to the class object, the object type they are. So v pointer will point to the object type they are. So flu one is a flu object. So you do new, right? You do new fruit. So they already saying that it is pointing to the one on the flu class. You know what I'm saying? So your new orange, that one actually already V table will point into the orange one. So say if I do through to peel, I go to the V table here and then go to here to the derived class. But there's no peel, so go back to its parent. Is that okay?
Yep.
Is that okay? So basically you create a object and there will be a V table, and V table actually have a few V pointer, and V pointer if the function exists on the derived its the own class, you will go to just there. Okay. If not, you will go back to its parent to find the implementation for the method. Is that okay?
Yes.
So this is how dynamic linking works, and C++ allow static binding and also allow dynamic binding. So if you want to do dynamic binding, you do virtual function. If you actually don't do a static function, you don't need to specify virtual. It's different from Java. Java, everybody are actually all dynamic. Java, every function is dynamic. And they will find their implementation at runtime. And C++, the programmer has the capability to specify whether it's virtual function or non-virtual function, or normal static binding function. Is that okay? If you do not put the virtual, it means it actually is a static function in C++. Okay? So that's dynamic binding. So V table is created for every class that declare one or more virtual functions. So here it says virtual function. If you have virtual function that actually dynamic linking function, you will search it at the runtime and it will override a dynamic function. So such a class is called polymorphic class. So some of the class are polymorphic, some of them are not polymorphic. C++ has the object mix, okay? And Java, no. Java, everything follow inheritance and same polymorphism. Every function is dynamic. Is that okay? So Java, you don't need to specify the virtual. Virtual means if I don't have definition, go back to my parent. Okay. Now virtual means that I actually will find the implementation right associated with my class. Is okay? And because it's right associated with my class, so it will be determined at the compile time. So that's static binding. And if you put a virtual, means that I will have a virtual pointer and that virtual pointer point into my derived class. My derived class may have the implementation, may not have the implementation, and we find the implementation at runtime. So because it actually had to be determined which function to run at the runtime, so we call it a dynamic binding method. And with that dynamic binding method, your object can behave like an orange or can behave like a fruit, okay? And that we call it polymorphic method. Is that okay? Same fruit pointer may pointing to a fruit object, may pointing to a orange object, may also pointing to a banana object if it's also under fruit class, may also pointing to an apple class. Okay, so we don't know what object it is and which function it runs really depend on the definition of the virtual pointer, and virtual pointer pointing to the virtual table in the derived class. A virtual table determine whether there is implementation in the class already or no. If no, you go back to the parent class to find the implementation. Is that okay?
Yeah, I have a question about well, if there's a class that isn't derived, it's just a base class, and it doesn't have any virtual functions, does it still have the virtual table?
There's no need for this.
Right. Okay.
Yeah. Well, virtual table is created for dynamic linking. You don't have dynamic linking. There's no such a need. So here, left-hand side is the implementation for the fruit, right? Right-hand side is orange. Okay, a little bit blurred. It's okay. Here you say public fruit, so you inherit no degradation, right? The visibility is the same. Fruit public extension actually means that you don't have degradation in terms of the visibility. Okay. So here we have orange, and here we have eat function, right? You have eat and peel in fruit, right? So here the eat is say it's actually virtual. So two implementation, one implementation here, two implementation here, right? Peel also actually declared as a virtual. Okay, so it is virtual, so but it has the implementation by itself. So there's a v pointer pointing to the runtime it can determine, right? So now it determine it said it's virtual. So orange do not have implementation. So once you call the PO, you will come to here to find this version. But if this one PO actually has what? Has implementation, right? Has an implementation. And at runtime, you will come to this PO and run it. Okay? But if here it actually do not specify a virtual, and you actually do what? Do through fx pointer fx equals new orange, right? You create orange object, but assign to a through pointer, right? But this through pointer actually is a reference to here, and their PO function is not virtual. Sorry, it is not going to run this version. It will run this version. It will not allow its child to actually do polymorphism. Is that okay? This one is not shown in the previous slides. It did not say that my PO is virtual. My PO actually is static binding. Is that okay?
Yeah, so it's not going to treat fruit as an orange in this case. I mean, it's fx is not going to be treated as an orange object anymore.
No, actually, you have orange. Orange may have an implementation for PO, right? But this PO, since it's not shown up in the orange, so actually you are using fruit object, so you treat it like a fruit object. And it actually will find this implementation here. So unvirtual means don't change for me. I do not allow you to actually override me. Is that okay?
Right.
Non-virtual means that I have physical link. Follow me. Okay, don't actually do anything. But virtual means okay, I'm virtual. If you want to override, you override. Is that okay?
Yeah, and if it's not virtual and you specify it in the subclass, it's the compiler isn't going to flag it.
No, it won't. It actually depends on if you do orange star 01 equals new orange, it will find this version PO over here. Is that okay?
Yeah, okay, yeah.
If actually you do through pointer F1, sorry, that would be this one if it don't have a virtual.
Okay, yeah.
Yeah, is that okay?
Makes perfect sense. Although it's
but Java doesn't work this way, okay? Java AV1 it's different, okay? Java all polymorphic. So that's we have a subtype of polymorphism, the ability to derive a class in the context that expect base class is called subtype polymorphism. So what we see right here is subtype polymorphism. So here we have a class person, and there are two subclass, student class and professor class, right? And student and professor P, student S and professor P are two objects, right? Two objects. So we assign the address of the S to X. So X is a pointer to a student object. Y is a pointer to a P object, okay? And then base class, we have print mailing label, okay, print mailing label and polymorphic method. So if we had a polymorphic method, so it actually defined in person class, it actually is a virtual function. So since it's a virtual function, so actually what? S.print mailing label and P.print mailing label, they will print these mailing label in different flavor, right? Is that okay? They will print this in different flavor because they are actually a polymorphic method. Okay, so if we do second one, static and dynamic binding one, okay, we do student column. So we specify the definition already. This one S.print mailing label, okay, and we actually will run student and using student as a defined domain and then run the print mailing label. So you will get the version that is defined in student object. Is that okay? Second one. Yeah, then we use the pointer. Okay, pointer, we have X pointing to the printing mailing label. So this one, actually, we do not know what type it is, right? This one. Okay, this one we know because you have student and professor. Okay, so we actually will do based on the static or dynamic, we'll find the right version. Okay, this one, the pointer is person type. We don't know which one you will run, but it will depend on the person whether it's defined the mailing label virtual or not. Is that okay?
Yes.
Yeah, determine the runtime. Is that okay?
Yep.
Yeah. Semantics and performance. Okay, here we have a text file. Okay, and then right hand side we have read ahead text file, whatever. Okay, so the principal argument against a static method binding is that static approach denies the derived class control over consistency of its state. So static method has such a drawback that actually you cannot actually change the different flavor of the function implementation. Okay, and dynamic linking you allow it. Okay, so for example this one. Okay, so so basically you will get the same read ahead text file method. Okay, yeah, so this one is just talking about it may have problem because you are pointing to the same pointer doing the same thing for C, but the file may be like maybe from hard disk, maybe from SSD, maybe from different device. They will have different feature, so you do not allow the polymorphism. Okay, and virtual and non-virtual method. Okay, a virtual function or virtual method is an inheritable and overridable function. So keyword overridable. I say virtual means that means I don't have implementation in my class, but I allow my children to override it. Okay. Okay, that's the only thing. So here, say virtual means, okay, go ahead. If you can update, you update, okay? I don't care. That's actually the base class definition, okay? Class Y type, okay, ADA, okay, ADA. So basically, you also have the procedure of different type, okay? So you define a pre-mailing label based on the data type you operate, okay, to determine which function you will run, okay. And you can have this print appropriate label, and this one you pass in a person quote right quote class. So not R actually is some class under the person, okay. And here at this time it determines you use person definition or you use student definition or you use a professor definition. So here is a class-wide type, in which case all call to method or parameter will be dispatched based on the class of which is it referred to. So based on the subclass type. So this one actually only talk about it is actually a class under person. Which class? I don't know. Maybe this one, maybe this one, maybe this one. And the version you run will depend on which class it is. Is that okay?
Yes.
Okay. C double plus refer to abstract method as pure virtual method. Abstract method means no definition. So pure means here you assign a zero that actually means pure. Okay, this one actually in Java or C sharp, you do abstract. But in C double plus, you write equal zero. Is that okay? You put it virtual. Virtual already is need to read. Virtual means you can override, right? Virtual means you can override. And then you put a zero means that I don't have the implementation. So the subclasses need to override. Is that okay?
Yes.
So here means that this person class, there is an incomplete method called print mailing label. And this one already is an abstract method. And it doesn't say it's an abstract method, it says it is virtual quantity method. Quantity means equal zero, right? It's just like you have a quantity symbol for electronic wire. Is that okay? I call it quantity. Okay, virtual and quantity. We call it abstract method. But the name is not abstract. The name is virtual and quantity. Is that okay?
Yeah.
So in C double plus, there is no interface, no abstract class. So in C double plus, everybody are just classes, okay? And if you have a certain quantity method, then you are abstract, right? And if you only have quantity method and no data, no other things, then you are an interface. Is that okay?
Yes.
And here you may have integer, you may have data here, okay? You may have integer here, okay? And nothing, you don't have virtual, you don't have virtual quantity method, you don't have, you can have a virtual, okay? You can have virtual for concrete class. But you cannot ground it. If you ground it, do not implement it, then it becomes an abstract method, abstract class, okay? So C double plus, everything are just class, no interface, no abstract class. Okay, they assign abstract class and actually the interface by using the quantity method. Okay.
So if something is only abstract, can you still create an instance of it?
Can still create instance of it? No. Usually we don't do that because you have unimplemented method. How can you run an unimplemented method? No. So people figure out this just to make C double plus work, but actually if you do use it as a constructor to build something, I think you will have a method that you cannot run because it's no definition. Maybe you run, but actually not going to do anything. But if you say cute, okay, and you say abstract class, okay, interface and cute, cute is defined in C double plus, okay? C double plus is actually purely written in C double plus, but it has a class called I controllable, right? So it's an interface called controllable, but it actually is a class. Is that okay?
Yes.
Is that okay?
Yep.
So I my interface, right? But it's a class. So actually that's the way actually it mimic the Java type of thing. You know what I'm saying?
Yes.
Is that okay? You use I something, but it's still a class. Okay, but you can see that actually Qt has object class. So it make so when they develop the Qt platform framework, right? They do have the concept of object class and interfaces. Okay, they do have that, but they just use a C++ in this type of way to mimic the Java's type of inheritance. Is that okay?
Yes.
So Java way of doing OOP still be the prettiest things that you can have. You know, there is no too much ugly feature. Okay, so we have, say we have a dog of the abstraction. You have 3 type of dog, right? Dalmatian, right? Collie and then the black, whatever. Vehicle, you have boat, a plane, and car. Okay, so this difference in implement vehicle, and vehicle actually is an interface. So vehicle can only have method. Okay, and the abstract class, you can have method, you can have data, you can have motion. Okay, but interface you can have multiple implementation, but object class you can only have single extension. Okay, so usually we define something like this. We have a class that actually extends some object class, then it implements some interface. Usually we do that. Okay, and this object class can implement multiple interface. Okay, and this one can also implement a couple of interface. Usually we do that. Okay, so object class usually is data centered. You may care more about the data. Okay, here we have 2. So static binding, the compiler can always tell which version of the method to be called. Okay, dynamic binding, the object referred to by reference or a pointer variable. Okay, to find. So the technique that actually C++ use is using v-table. Okay, Java is not using v-table. Java actually, because everybody has the linking, so Java will directly pointing to the when you have a class, Java will automatically pointing back to its method area. So the whole class implementation body is in the method area. Your object will directly pointing to that. And if the object actually cannot find the implementation for Java language, they will find the parent class that the object extends. So you actually will be able to trace back to the different object, to different class to find its implementation. So the way that it is implemented in C++, is different from the Java implementation. So Java don't use the v-table. It's actually simpler. Okay. So here let's look at a virtual method code. Okay. So we have a full class. We have integer A, double B, character C. So here we have integer A that will put the data A there in the full object. Okay. Then we have A, B, C. C actually is a character, so it's shorter, right? Right hand side you have fools table. So that fools table is v-table. Okay. It's v-table. You have 4 virtual functions: void K, integer L, void M, and double N. Right. So that actually had 4 full methods. Okay. So now what happened is that then we call a function fm. So we call the m function, and we call the m function. So we actually do what? We try to find m function. So go to the f class, f object, right? And then we find an m function, m pointer, and then using the m pointer, we find the m's body, right? We find span body. So that's the calling procedure. So actually you do f pointer to m. So the object actually is this f object, right? And you actually find in here and then pointing to here and find the function. Okay. Okay, in terms of calculation of these, actually, let's see. Actually, we have cell pointer is R1. So F object is actually this object F. Okay, I think this should be capital F. Okay, so F object actually is R1. Okay, so F object's address passed to R1 register. Okay, and R1 registers body. So actually it's a pointer. So you pointing to this object. Okay, so let's use as F as a pointer. capital F as an object. So the body of the R1 is stored in R2. So R2 actually is the address over here. This is R2. Okay, the address here is R2. Okay, so R2 actually do calculation. This calculation, right? R2 plus 3 minus 1. 3 minus 1, this is 3 minus 1, actually is 2 times 4. So the offset from here to here, from the calculated offset from here to here, okay? And each object, its address, its object, I mean its body is this body assigned to R2. So R2 being assigned with this value, and that R2 actually is the M function's body you make call. Is that okay? Is that okay?
Yes.
One more time. Okay, one more time. Here, this one very crucial. So here, that's assume this is a pointer. So F pointer pointing to it. Try to run this function, right? F pointer actually is called R1. So its address is R1, right? R1 is a pointer, so it's pointing to here. So it's body of the R1. Body of R1 assigned to R2. So body of R1 is this object F assigned to R2. So R2 now actually is this location. This location is the first point. So it's also the pointer to the full table. So full table and then offset by 3 minus 1. That's the offset times 4. 4 is jumping to here. Okay, and its body means the pointing to here is the body here. The body here actually will be called, and that is finishing the code here. Is that okay?
Yes.
Yeah. So that's how it is wrong. So when you read the textbook, this textbook is well designed. Okay, actually, it put a lot of information there. But if you really study, it's really hard to trace it. I mean, if you don't pay attention, it's hard to understand what's going on. So here, implement of single inheritance. Okay, if bar is derived from foo, we place additional field. Okay, previous one is actually the foo class. Now we have a bar. We have a bar object. So bar object actually inherit the full object publicly. So no degradation in publicity, the visibility. And here we have a W. And this W is an integer. So we have one more data field. Virtual function originally up to N. Now actually override. It say override. And then 2 more. Okay, so this one actually you redefine it. Override means you redefine it, okay? And then 2 more function over here. So here you have 3 new implementation over here. Is that okay? And foo already declared this M is a virtual function. So here you redeclare it, you should be able to override it. Is that okay? You redeclare it, you should be able to override it because foo already allow you to override. Right? You say that it's virtual. You say that it's virtual here. You say it's virtual means that, okay, I'm virtual, so you do whatever override you need. Is that okay? I'm virtual. I actually allow you to change. Okay?
So
I allow you to change.
You need to add this keyword override to actually make it an override?
No.
Okay, so
you just do implementation, it will be fine.
Okay, yeah.
I think this one is just telling you that it's an override. Is that okay?
Yeah.
This one is not really, it's a virtual pseudocode. I don't think it's putting the override over here. Is that okay?
Yeah, makes sense.
Okay, anyway, here you will find a new implementation through this point. Is that okay? Is that okay?
Yes.
Okay. Anyway, so 3.1 actually will have new definition over here. Okay, 2 are actually new over there. So dynamic binding for downward assignment, upward assignment. Okay, here let's see. We have we have a full object. So full is an object F type, full type. Okay. B object is actually is a bar type. Okay. And then we have full pointer Q. Q is a pointer, so it's a pointer to full object. And then we assign B's address to it, so this become a full pointer pointing to a B object. Okay. And then S is a bar type pointer. S is a bar type pointer. Okay. Bar type pointer, we actually use bar type pointer and use assign the address to this S bar type pointer. So a bar type pointer pointing to full. This one is wrong. You can assign parent object to a child reference or child pointer. Is that okay? Is that okay?
Yeah.
Because what? Because of what? Because your child class has more data field. Your parent object doesn't have it. So if you call some function, they may not have the implementation. You reference from data field, you may not have the data field for the child class. Is that okay? It's for the child pointer. So in that case, you cannot use the parent object by a child pointer. Okay.
Yep.
Same thing for Java. Okay. Parent object can never be assigned to child reference. Parent object address cannot be assigned to child pointer as well. Okay. Is that okay?
Yes.
And that actually create a big problem here. The object type we don't know. So C++ allow backward assignment by means of dynamic cast. Okay, it is wrong, but if you insist you want to do it this way, dynamic cast. So convert D Q to S by dynamic cast. So it actually means that, okay, you still want to do it, okay, I would let you do it, okay, but I will just allow you to access some data field that you have. Is that okay? That is dynamic cast. If you use this one, bar star, it also can cast it, but risky. Is that okay?
Yeah.
So in C++, we have two more casting. Dynamic cast and static cast, okay, and that you have to study. Okay, you actually, if you are interested, you can study C++ static cast, dynamic cast. Okay, they are different, and you can find internet, and there are people discussing these things. Okay. It's okay, and it's been quite a long time, so you probably, if you are interested, you go and study it, okay? But people say this is safer, so do it if you need it. Is that okay?
Yeah.
People say that this is safer in C++.
And it's probably even better to just avoid it altogether.
Yeah, just write it. Actually, I know it why, but after a while I forget it. So you just try to use it that way, okay? Okay, dynamic binding in Java. So here we have forecast. We have these different forecasts. So there is an M function deal with object X, okay? And object X, you can pass a graduate student to it. You can pass a student to it. You can so object is the highest one, and then you have person, and you have student, and you have graduate student. Okay, that's the inherited tree. So this one, actually, we start from here, okay? And then we actually see a graduate student, right? So that graduate student pass to M function here, right? And then you perform the toString. You perform the toString because X is actually a graduate student. So you will run the graduate student version, graduate student no version, no implementation, equal to student. Student will print student. So this one print student. Then student comes also print student. Person comes, person also print a person. So student, student, person. Last one, object come is actually print our H code. Okay. So that actually how dynamic binding is doing in Java. So Java, you just trace back different level if you don't have the implementation. We call it the binding chain. Okay, it's actually run by binding chain. Is that okay?
Yeah.
Reverse assignment in Alpha and C#. Okay, this one I pass it. Okay, this one actually I don't think it's important. Okay, next one, function closure. Function closure is this one we have. Well, this is used for what? When you actually need to pass a function as a parameter. I talk about this in C language, right? You can pass a pointer to a function as a parameter to another function. So how can we do it? How can we do it in Java? Java have no pointer. Java have only a reference. So let's do this one. We create a plus X object. Okay, plus X object actually implement in function, and in function has a call function. So anybody say plus X minus X multiply X. Three different functions. These three different functions can be put into plus X object, minus X object, or multiply X object. Okay, so for example, here we have a plus X object. We create a new plus X object, but I actually assign to here in function interface. Then this one is plus X, and then 2 being passed there, 2 being passed there, so X being set as 2. I'm sorry, X being set as 2. So X is 2. So whenever you call the function, the data 3 will be provided here, and 3 plus 2, you will get 5. Is that okay?
Yes.
So now, if now after this one, if I say f equals new minus x, right? I put 5. Okay, I put 5. Then actually, for example, in minus x function, I assign the 5 to x, so x become 5 in minus. Suppose this one is minus. Okay, then I do f dot call 3. Now this time becomes 3 minus 5, it becomes minus 2. Is that okay?
Yes.
So f can accept different function. Is that okay? Okay, let's do this one in Java. Okay, it's actually easy, so let's actually do it. Okay. So let's see this one. Call it, let me see. Is okay. This one is called it function closure. So it's an interface in function. Okay, so here delete it. Okay. So here actually it's an interface. An interface I here actually do integer call integer I. Is that okay? Okay, this one is a function. It will return integer type, but actually equivalent to you actually have the public option. Is that okay? Even if I don't write it, you still have this one. So there is the interface call this one, and it actually will call, provide call, and then do that. Okay, so now let's do this one, K plus X class. Okay, so this plus X class, actually this guy, it actually implements in the function. Okay, so because it implement in function, let's see here, implement in function. Okay, so let's do here. I have a integer n x equals x, okay. And then I have plus x, okay, and then I have an integer n, and then my x will be equals to n, okay, and then here I implement the call function, so actually integer call. So I actually do public integer call, and then here I have integer x, okay. Don't do x, let's do actually I, okay. So return I plus x, right? That's what they say, right? Okay. So this one actually let's do another one called minus x. Okay. Copy the whole thing over. Okay. So here this one's minus. So this one minus. Okay. Compile. Okay. Let's put one more multiply. Okay, multiply. Call it mal x. Okay. Same thing. Let's actually copy up here. Okay. Okay. So pretty good. Okay. Pretty good. So now let's do test functions. Okay.
You need to make the...
Yeah, don't worry. Yeah, I see. Yes, don't worry. Okay, I have a function called is Q, right? And it's Q, I can pass S2, M2, and the P2 to it, operating all on the I equals 5. So I'm going to run +2, -2, and multiply by 2, okay? So the function being passed, my value being passed, and you will do a function by that, okay? So let's call it, okay? Let's call it, and then let's actually run it. So I get 5 + 2, 5 - 2, and 5 times 2. So I successfully passed the function. Function itself is an interface object, okay, object actually, but it actually been represented by the interface as a reference. So the interface reference being passed to there, and that interface can do call, and that call actually defined in the interface here, okay. So every subclasses will have the call. Every subclasses will have the call. So you pass a reference of the interface function type, you will be able to run code. Code is okay, and actually can pass a parameter to it. So that parameter being passed to here, and I actually can do +2, -2, and multiply 2 for you. And as long as you pass me the function. So function closure means you can use a function as a parameter, and you can pass it to somewhere like this. Is that okay?
Yep.
Yeah. Let me see. Okay, one moment. I lost it. Okay. I actually don't have it. Actually, my son write a integrator and a differential equation. So here this is Q. If here right here, you change it to integral, right? You pass in T0 and T1. The function here, you can put a function f of x. So you can put the parameter T0 and T1. And this one do integral. You know what I'm saying? You should be able to do an integral as long as function pass in, and that function say you can have a sine function, and sine function being passed to here, and you do sine function integral. You put the cosine function over there, you do a cosine integral. You know what I'm saying? So this integral or SQ is an engine, calculation engine. So you can pass different function into it and long it. So that actually answer your question before that. Why am I going to pass a function as a parameter? You can do it in this way. Integral derivative, finding the derivative is the same thing. You know what I'm saying? Finding the derivative also the same thing. You can pass it to the problem solver to solve it. Okay? So here just show you like why here suddenly there is a need for doing this object closure, and it's done in Java way. Okay, this one is done in Java way. Let's look at there may be some other language. Is that okay so far?
Yeah. Yes.
So here is C double plus way. So C double plus way is like we need an interface, right? So we need an interface. So we actually have a grounding method, right? Right? Grounding method. And here you actually call operator parentheses. Operator parentheses means that you have the parentheses. You will do it for you. Okay? It's actually a function parentheses. Unary operator. Okay, unary operator with integer. So this one is a constant integer. Okay, so that's a plus x function. So plus x function, you have input here. You will set the x to n as well. Here you have the operator this. It will perform this one for you. Is that okay? So actually, effectively, this one is the same as Java plus x. Is that okay? Is that okay? So now let's look at the second part. Second part, you have apply a with this. So the function pointer, a function reference is put it here. Okay, so you have an array being passed here. So each array element will be performed for a size time. You run the f function for each individual one. So that actually at the end means that apply the +2 function to the array A with 10 elements. Is that okay? Is that okay? It actually eventually becomes like apply +2 function to array A for 10 elements. Okay? So, but this one actually just tells you like passing the function as a parameter in C++ case. Okay? Similar to the previous one, but you can learn how C++ is doing it. Okay. So you can encapsulate in the arguments. Okay. So next one. Here you have a class. We have the function called class. That one, your operator actually is grounded. So here is a interface function call. Okay. So that one is the interface function call. And we have a schedule add. Schedule add is a connector. So connector, you have function being passed there, and there's a time associated with the function. Okay. Now we have a full function that will take integer, double, and character type. Okay. Now we have call full class. Okay. We have argument 1, 2, 3. Okay. Then we have call full function that actually take in argument 1, 2, 3 and set it to the 3 variable. So call full actually is what? Actually call full actually here is a constructor. So you set up the initial value for argument 1, 2, 3 only. Okay. Operator actually is the function call function. Call function you call full. Full will actually calculate the argument 1, 2, 3 based on full function implementation. Okay. So now we actually call full. So we create a calling full object 3.14 and x. Okay. Then we schedule that function interface to be run from now with a certain delay. Is that okay?
Yes.
Yeah. So this one is the same as previous one, but it actually has a scheduler in between. Okay. What is this useful? This one is sometimes useful when you need to call your unit system call in the midnight. Is that okay? In the midnight. So a certain function, I set it up, I actually run that function, and that function can be changing. So this time I maybe swap in the disk. Next time maybe kill 300 process. But I actually can schedule them a certain time to run. Is that okay? Function can change, time can change. Is that okay?
Yes.
So that is this one. Okay. So that's the standard closure. Okay. Function closure, table of function. Okay, this one I tell you before. Sometimes we would like to have a table of function. For example, interrupt function, you have several function, and you need to call the interrupt by its index. Okay, so you can pass a function actually can be a table of functions. Okay, so function level class on the right side you have function table. You have function level class with parameter. Okay, how you define different function. So right hand side you have a function. Actually, it's a function object f. You bind with a certain function and some parameter. That's called function object. So we can call that function object by f3.14x. So this one actually is a function closure type in STD. And by doing this, you bind with some function with a parameter, you will be able to run it. Is that okay?
Yes.
Is that okay?
Yeah.
So this whole thing is just to bind. This, you have to study function. Function is a library in C++. It allows you to have systematical way of calling function by using a function closure. Is that okay? So include functional, you get this function object. Is that okay? So what I really want to say here is C++ has a systematical way of calling a library. You don't need to write your own. You don't need to write your own integer function interface. Is that okay? C++ will have someone written for you with that type of the interfaces that called functional. Is that okay?
Yeah, so that's like functional interfaces in Java.
Yeah. And here, actually, I have an example you can download from the school website of trying out the functional. Is that okay? Here, I wrote it 4 years ago, and you can download the program to try it out. Is that okay?
Sure.
Yes? Question?
Yeah, thank you.
Yeah. So I don't go into detail. I don't run it. Okay, you can download it to run it yourself. Okay, mix-in inheritance. Now we go back to the Java mix-in inheritance. So mix-in inheritance means you have interface, you have abstract class. Okay. So left-hand side is called multiple inheritance. You allow multiple parent class. Okay, let's call multiple inheritance. Right-hand side is single inheritance. Single inheritance means that you can extend one class at a time. Is that okay? Is that okay?
Yes.
Yeah.
So middle is mixed in. So you extend one class by implement two interface. That actually is okay. Right-hand side, actually this one single inheritance actually really means this one. You have green, right? Let's just do this one. You have green, right? And green actually inherited brown first. And then it becomes green with brown, right? Then it inherited red for a second, and it becomes red, brown, and green. Is that okay?
Yeah.
Yeah. By single inheritance, you can implement all these three functions by doing three extensions. Is that okay?
Yeah.
Effectively, it's the same as this, right? Effectively, it's the same as this. But you do three steps. Is that okay? Effectively, it's the same. Any question?
None from me. Thank you.
Effectively, it's the same. Okay. So that's explain you how we are going to do multiple inheritance if you need it in Java. Okay. So this different language, I don't care. And where are we going to use this inheritance? The motivational interfaces. Okay. So we have Windows 10 widget. Windows 10 widget are these: battery level, hard disk drive level, performance, Spotify interface, daytime, Wi-Fi, weather. So these are actually widgets that it can show on your Windows 10 cell phone, right? Or maybe also your pad, right? Smaller device pad. You can actually implement some software and bring up this widget pretty quick, right? So these different widgets actually are objects, and they may inherit something. So these are actually the background, actually the reason why we want to do this kind of OOP. So capture the requirement of the Windows system. Language with mixed-in inheritance allow the programmer to define the interface that the class must provide in order for its object to be used in certain context. So widget, the reporting system defines a sortable object, graphable object, and the storable object. So here we have three types of interface: storable, sortable, graphable, and storable. Okay, so widget system have these three types. So an interface as class contains only abstract method, unimplemented method. Okay. So here explain the class and interface. Okay, I actually will move on to the next one. Okay. So implementation of interfaces. Okay, this one. Okay, it's a V table. We don't spend too much. Let's jump to here. Okay. So we have widget, name widget, and augmented widget. So augmented widget implement actually extend the name widget. Name widget extend the widget. So pure widget is just like an object. You have nothing, right? Name widget actually is, because it has a name, so it becomes a sortable. So you implement a sortable object. Okay. Augmented object, it actually is also storable. So it's storable and graphable. So actually it allows you to, it is allowed to do graphing and storage. Is that okay?
Yeah.
Yes.
Yeah. And we have sorted list that only actually operate on the sortable object. Is that okay?
Yes.
So this one actually, as I mentioned, this is called use relationship, right? So this function use these objects. Is that okay? This function use the object. You want to show it, the object must be graphable. Otherwise, your browser cannot do it. Is that okay? Yep. Your dictionary want to show it, the object must be storable. Is that okay? Your sorted list want to do it, the object must be sortable. And the widget, you may have some widget that actually doesn't apply anything, cannot be sorted, cannot be put into browser, cannot be put into dictionary. Some then widget can be sorted. Some augmented widget maybe can be done for everything. Is that okay?
Yes.
And those widgets are what we talk about here. The widget system of the Windows. Okay. This one I put in here, but I know that the author is talking about this. Okay. So now we have interfaces in Java. So left-hand side, we have Java language. So class widget. Okay. Class widget has a sortable object, graphable object, and a storable object. So here we have class widget, and under it we have three interfaces, right? Then we have name widget, extend widget, implement sortable object. So this one actually is just to show you the chart I draw here. So in the textbook is those texts, but I actually show you the UML relationship here. Is that okay? Whatever you read here about widget and the object, it actually shown here in this UML. Is that okay? Is that okay?
Yeah.
So here we have sortable class, we have browser window, and we have dictionary. And they are functions inside the class. And you can do insert, and now those will operate on the sortable object. Will all actually work on the graphable object or work on storable object. Is that okay?
Yes.
Yeah.
And here right hand side explain to you dictionary that insert will do what. Okay? Okay?
Yeah.
So here just to show you that interface usually give you some sort of capability. An object that can be sorted, an object that can be graphed, an object that can be stored. So usually the interface name is sortable, graphable, drawable, storable, comparable, right? Iterable. Is that okay? Something iterable. Something you can do. Is that okay?
Yes.
Yeah. So compile times in here. Okay, it's okay. And this one also show you how to calculate ages. So I don't go through it again. Okay, this is similar to the previous one. Okay, still V table calculation. So this one, let's see this one. We have object, we have widget field, we have sortable view interface, and then there's an offset ABC over there, right? By different offset, you can calculate where the object being stored. Is that okay?
Yeah.
Is that okay?
Yep.
Okay. Yeah, actually we don't. So multiple inheritance. So C++, you can have professor, extend teacher, and also extends researcher. Okay, so that's called multiple inheritance. Multiple inheritance, you take over all of the data field and also functions, right? But who you do first and which one will be empowered? Okay, it's the topic we are going to talk about here. Okay, so professor had print, teacher had print. Okay, researcher also had a print. Okay, so we can actually do what? We can actually re-implement the professor T print and the R print so that we don't have a duplication for print. Is that okay?
Yeah.
But this involves the change of the class, okay? If not, the true multiple inheritance, virtual-based class, the usual case that you inherit from two classes that are both derived from some other class B, your implementation should include two copies of B. If you have B class and you have C class actually implement B class, you also have D class implement B class, right? And then you somehow have the E class implement both, extend both. Then E class will get two B class. Is that okay?
Yeah.
And that's stupid, right? So then you need to make the B class as a virtual. Is that okay? Is that okay?
Yeah.
How big is that?
So as you can see here, like because of the multiple inheritance, actually it's quite stupid. Okay, so here we do have a conclusion for object-oriented programming. It's analog to the real-world problem, and especially when it is involved with the event-driven programming. Okay, and we try to talk about different way of using this object-oriented programming, especially three major concepts that is important in OOP: encapsulation, and inheritance. And then last one is polymorphism. Okay, three important concepts involved for OOP. Okay. So OOP actually is more modularized. It supports event-driven programming and it supports concurrent programming, but concurrent programming will be the chapter 13. Okay, it supports distributed computing is also in chapter 13. And graphic user interface is related to event-driven processor. So OOP means Windows, right? Means multi-threading. Several processes can run at the same time. Is that okay? Yeah. That's the main purpose here. If you just want to do A function, call B function, call C function, you don't really need too much OOP, okay? OOP become popular just because the Windows 1, 1985, the Windows 1 happened. Is that okay?
Yeah.
And become popular in 90s. 92, 93, Windows become more popular. Okay? So Smalltalk is the great part, but actually I studied Smalltalk before. I have a textbook on it. I do self-study on it, and then I cannot find compiler. So I give up. I actually cannot run it. Nobody has a software. I know it's the first object-oriented programming language, but I cannot find a compiler for it.
So is the compiler proprietary? Or?
No, actually, at that time I was in my college in Taiwan. We don't have any copy of it. Yeah. And I think even in the US at that time, not popular. It's just mostly in university and somewhere, not every compiler is available everywhere. Okay. Yeah, but we do know that it's the first object-oriented, popular object-oriented programming language. Okay, these are fine. Ada, okay. Is C++ object-oriented? I would say yes, but actually is a. I told you actually C++ actually has a C living inside, right? It has a C living inside, but C++ is outside. So in fact, it actually is a C language. Okay, so you must be good at C for you to be able to know C++ better. So a lot of things actually is low-level C stuff. Okay, it escaped the paradigm. So C++ cannot be considered as a pure OOP. Maybe the OOP just about 70% for C++, maybe just 70%. Too much low-level stuff. Okay, bypassing the rule of OOP. Is JavaScript object-oriented? Yes, it's pure object-oriented programming language. Pure object, not even class. Don't have class. Okay. Don't even have class. Other programming methods. Okay, we have Prolog. Common list. We are not going to cover it. Okay. And next talk on Wednesday we'll be moving on to the chapter 13, concurrent programming or multi-threading. Okay. Any question over here?
Nope.
Nope. Let's see. We just 11:20. Okay, I'll send this one to you. Okay, don't worry. Now let's go back to this guy. I'll try to show you, right? But actually, I do not have the full time to do it. So can I do this? Can I just do? Yes, okay. Can I do just copy? Talk and copy, is okay? Let me see. It want me to uninstall it wants me to uninstall the Arduino. Okay. So now we actually continue this one. Last time we talked about rectangle. We talked about square and prism, right? And we are moving on. We also need to show you this one, oval. Okay, oval. Okay, we want to show you this oval. And also want to show you these two, oval and rectangle, to be integrated with geometry. And geometry actually is a abstract class. Okay, so I'll try to demo a abstract class for you. So this still be within the OOP, but I will try to give you an example. So last time we finished this, right? So now we are going to do oval. So but here I don't do the whole writing again because we don't have that much time. So let's get started here. Okay. So we do have an oval. Okay. And then let's clean this. Okay. So rectangle, you have a private double width and height, and oval has here. Let's do the constructor and the data here. So we have AB, and we have two data here called AB. Okay. So what is AB for oval? What is AB for oval? Okay, your square or your rectangle is width and width and length, right? Is that okay? And if you have a height, there is another one for height. And oval actually is like this. So you have A and B. So when A equals B, it becomes a circle. Is that okay?
Yeah.
Yeah. And the area for all this oval is what? Circle is pi r squared. So it's pi times r times r. This one's oval's area is AB pi. Is that okay?
Yep.
Its area is AB pi. Okay, so here we have this one. So let's do get axis and set axis. We call this A and B axis. Okay, so these are something I can actually copy. Okay, and then get area I say is the AB pi, so it's okay. Equals is just compare A and B equals. Two string is okay. We have a two string, so let me actually copy up to here. Is that okay? This we actually don't need to talk about it, right? So let me actually put it down here. So I have this oval class ready. Okay, draw, I will do it later. Okay. So this one is my oval class. Now I have an oval, so that actually this one has A and B two parameter, and I have get A, set A, I have get area, I have compare equals for the oval, and I have two string. Good, that's good enough. Okay. That's good enough. Let me check the rectangle point now. Rectangle point now, you will do R. Okay, let me change. Since it's R, I'll just change to O. Okay. How about now I actually define something called circle. So circle, as I say, is an oval when the two axes are the same, right? It's actually called area is called AB pi. So here, let me delete this one. Delete this one. So the setter, getter, we pretty much can revise it. So we only need to create a radius, okay? And the A and B both are radius. And we have the get radius, set radius, okay? And then two string. Is that okay? So this guy actually quite easy. Then let's just copy over and pass over here. And this one we only need to do extends oval. Is that okay?
Yes.
Yeah. And the get area and equal, it use the version from oval. Is that okay? Get area and equal, we just use it. Circle now, actually, because it's a circle, I use a single digit system. So let me actually just print out C, okay? So that's my circle. So oval, circle is one kind of the oval, right? Next one is a sphere. Sphere is 3D circle, right? So let me actually copy it. Because Wednesday and Friday I'm going to use to spend time on multi-threading, okay? So today, that's the only time I can do this, okay? So actually, I try my best to give you some code and give you some information. Sorry for that I have to rush it, okay? So here I have a double super, get radius, set radius, and this one is 3D ball, right? Actually, sphere. It actually is this way, right? Is that okay? It's a ball, okay? Okay, so the area, surface area is 4 pi r squared. Is that okay?
Yeah.
Circle, ball, actually, the surface area is 4 pi r squared, right? And then what? And then the volume is what? Volume is this, right? Remember?
Yeah.
Yeah. And here, this one, let me change to S for single digit, okay? Good. And actually here equals you bypass, okay? Get area, because it's different from circle, so I actually return different get area. Is that okay? So now I also have a sphere class, I'm sorry. Okay, and sphere class actually implement circle. Okay, So now I finish that, and after that, actually, I can do test sphere. Okay, good. Okay, and I can do test circle. Okay, so the copy. This thing just to verify that test sphere, the sphere and circle, they are actually both working. Okay. So here what? So far we actually show you two different inheritance structure. One is a rectangle group, one is actually oval group, right? And here we have test oval. Okay, test oval. Let's do one more. So test oval will be test oval class. Okay. Okay, so test oval is here. We actually can also run it. Okay. Good. Now this side we have test rectangle, and rectangle put everything into array list, and we actually test many rectangle. Okay, this side we actually can test array of ovals. So let's do this one. Okay. So left side test array list, the right side test arrays. Oh, I need a class called ovals. So let's see. Let me copy the ovals here. So I have one more class to copy. So ovals actually has array of 5 elements. Okay. Okay, good enough. Okay, pretty good. Okay, and then we can test these different ovals. Okay, now sometimes I need to operate both oval and rectangle. How can I do it? So I need to have a something called geometric class. So let me copy this one over. Okay. So it actually, well, your ovals area is different from your rectangle area. So I had to put the area as a what? As a abstract method. Is that okay? As an abstract method. Why? Because the area definition are different. Is that okay? Is that okay?
Yeah.
But each of the oval, I actually can compare the area, the two geometry objects, either oval or rectangle, by what? By its area. Is that okay? So two can actually be put together. So here, let me put here. Let's do this one as rectangle. Let's do extends. Okay, so you extend the geometric object, and you do not have comparative function. Okay, let me see. So this one I have to actually commit it out. Okay, I use its father's version. Is that okay?
Yeah.
I'll use the father's version. I don't need to redo it, okay? So let's see. So here this one, actually, I don't need this one anymore because it's father implement comparable. Is that okay? Is that okay?
Yeah.
Yes.
Let me move this a little bit here, okay? Okay, now actually my oval also would like to actually extend geometric. So because it extends geometric, it also will use the function compared to defined in geometric object. So here I do not have the compared to. But actually is fine. I already have that. So these two sides actually now they are grouped together. Is that okay? Now the right side and right side corrected. So we can do test geometry now. Okay. So basically let's copy this and go test geometry. Sorry, I have to rush this one because typically this takes 1 hour to finish, but I don't have 1 hour today. Okay, sorry. Okay, right here actually you have rectangle. That means we don't have rectangle. So here that's actually this one. Let's put it here. Okay. And then I need to have this rectangle. Rectangle is pretty easy. Okay, rectangle just extend the radius of rectangle. Okay.
You're using the wrong window.
Oh no, I'm sorry. Yeah, that's it. So what does this guy mean? This guy Rex. What does this Rex mean?
It's a array list of rectangles, right? It's
Yeah.
Yeah.
So this one is a relationship. So rect is actually a radius of rectangle. Okay. This side almost actually has a array of oval. So this has a relationship. Left side rex is a relationship. Is that okay? Two are different. So I put this as a collection of oval, a collection of rectangle on purpose. Is that okay?
Yes.
So now let's compile it and then run. Yeah. So everything running okay. Here actually I have print already some geometry. So every geometry object come here can be printed. Is that okay? And I make a radius of GG, right? And then create oval, and then the oval actually each of the oval in oval array are being put into my GG. Is that okay? And each array list, artist, every single one also put into my GG. So I have some ovals, some rectangles, and the ovals can be circle, oval, sphere, circle, oval, can be rectangle, square, prism, square, rectangle. So totally 6 different data types be merged together to a R list. Is that okay?
Yes.
And then I sorted them. I can sort it because of the compare to function. Is that okay?
Yeah.
Yeah. Because compare to function, and then I can print it. So that actually is the feature of here actually show you like here actually show you what? Show you guys like I can add I can group two sides together, group two kinds of geometry object together. Okay. I can actually group two kind of geometry object together. But now, how about this? How about I want to draw my circle and draw my oval? I want to draw it. So I want to implement the draw function on both sides. On both sides. How can I draw it? So actually, I would like to make every single class be able to draw. Okay. So because I'm going to make every single class able to draw, so I will invent one more thing. I will put this interface drawable. So let's do this one. Create interface called drawable. Okay. So here we have an interface called drawable, and this drawable interface pretty much just do one thing. Just have a draw function. That's it. So everybody now need to implement my draw function. If you implement drawable, so here let's just do this one, comma drawable. So I implement the comparable and also drawable. So now because I'm drawable, so everybody under me need to have a drawable function. Otherwise you are wrong. Okay. So here this one no drawable. Geometry object no drawable. Okay, so it's not okay. Someone need to take the responsibility. So go back to here. So I go back to rectangle. Rectangle here actually has a draw function. So that rectangle take care of it. Okay, good. So copy, put into my rectangle here. And here let me actually override this one, put drawable here. Okay. And here I actually need to include the 2D stuff, include the AWT 2D stuff. Okay, good enough. So come to the oval, also put the 2D stuff. Geometric, okay. Yeah, so drawable, let's actually implement the drawable here, okay. Okay, put this drawable function also here, okay. So because my oval class and rectangle class both implement the drawable, so anything under it has no need to have that drawable, to have that draw function, okay. And this drawable require you to draw, and over here, these two top classes, they take the responsibility. So anyone under will use the function defined here, okay? Any function under you will use the function over there. So now let's do the last one, the drawing. So here we have test drawable. Test drawable, let's actually copy everything. Copy everything. Pass over here. So this one, you create a window of 400, 400, right? And then you start to draw. Okay, you start to draw. When you draw, actually you get everything from glist, right? And then randomly pick a color, and then randomly pick a location and draw that object. Okay? And the glist, where is glist? Glist, when you do drawable, you create the same object I have in test drawable. Is that okay? In test geometry object. Is that okay? So basically, I add in all the possible rectangle, square, prism, oval, circle, sphere together. And that's all test draw. Test drawable just draw it for us. Is that okay?
Yeah.
Yeah, and it do drawing. Yeah. Okay. It do drawing. Okay, when I move, actually, it change the window size, but it keep drawing. Is that okay?
Yeah.
When they eventually start to do drawing. Okay? Okay. That's it for today. Do you have any question?
No, not for the moment.
So what can you do today? After today, what can you do? How about this? How about it's not homework, but if you are interested, you can rewrite the whole thing here, and you will know Java OOP much better. Is that okay?
Yeah.
You start from rectangle and square the prism, then test, then oval, circle, sphere, and then test, and then has a relationship for ovals, is a relationship for rectangles, and then test array of objects, and then test geometry object, and then put the interface over there, and then draw. You rewrite the whole program. I believe you know everything that we talk about in this chapter 10. Is that okay? And for what? If you know object-oriented better, actually, every other language it should be easy for you. Okay? Okay. Any question?
No, I'm good. Thank you.
No question. I'm going to send this to you and also the function interface. Okay? And then
Awesome.
you guys
Thank you very
have
much.
fun, and then we will meet on Wednesday and Friday on the last chapter, chapter 13. Okay?
All right. See you then.
Okay. Thank you. Bye-bye
Thanks.
now.
Bye.
Have a good one.
Bye-bye.